All right, in class we've been solving second order linear constant coefficient homogeneous differential equations. And when we solve those types of differential equations, we often get complex roots. And when we get complex roots, we get solutions that look just like this. Often we'll have an e to something t out here as well. But initially I just want to focus on that part right there. If you graph a function that looks something like this, it kind of just looks like a regular old cosine wave. It has some amplitude, it has some angular frequency, and it often looks like it's shifted a little bit. Well, when a wave is written in this form, we often can't tell what the amplitude is right away just by looking at it, and we also don't know right away what the shift is. So our goal in this video is to rewrite a wave that looks just like this into a wave that looks something more like this, where I'm calling r the amplitude of the wave and phi the phase shift of the wave. Notice that this is a cosine wave which normally starts at its maximum at t equals 0. Well, this phase shift is going to shift that maximum to the right by phi seconds. You'll notice that we used omega here. That's the angular frequency. It's the same omega as we had originally in our cosine and sine terms. So if this comes from a differential equation, we can actually find a and b just by using the initial conditions given to us. So the question we have is, if we're given a and b, how can we find r and phi? So that's the question. I'm going to erase this right here and show you how to do it. The first thing we need to do is to remember this trig identity. It's cosine of u minus v. It's cosine u cosine v plus sine u sine v. Well, this is the situation that we have right here, so I'm going to rewrite this cosine term using this identity. All I have to do now is distribute the r. So I fixed this phi, I distributed the r, and I rearranged terms. And now these two lines look very much alike. You'll notice that our a corresponds to r cosine of phi, and b corresponds to r sine of phi. And this is great. This gives us a relationship between a and b and r and phi. But we're given a and b. So what we really want is an equation for r in terms of a and b, and an equation for phi in terms of a and b. Well, as it turns out, this isn't too hard to do. All you have to do is notice that a squared plus b squared turns into this right here. If we factor out an r squared, we get a really common trig identity. Cosine squared plus sine squared just equals 1. So we got an equation, a squared plus b squared equals r squared. I'll write it over here as r squared equals a squared plus b squared. Another quick thing we can do with these two equations is we can divide them. We can notice that b divided by a is r sine phi divided by r cosine phi. Obviously the r's cancel and you just get tangent of phi. So the other equation I want to write is tangent of phi is b over a. And these are the two equations you want to use to answer that question right there. Let's do a really easy example. We would like to convert 3 cosine 2t plus 4 sine 2t into its alternate form. You'll notice that the a value always goes with the cosine term, is 3 in this case, and the b value, which always goes with the sine term, is 4 in this case. You can use these equations to say that r squared is 3 squared plus 4 squared, which is 25, and then obviously r equals 5. Of course, whenever you take a square root, you could have a plus or a minus in here. Keep that in mind for the future. Using the other equation, we have tangent of phi equals b over a, which is 4/3. To get phi, all you have to do is type in the inverse tangent into your calculator of 4/3. Actually, that value is fine for phi. That's an exact value. So now our wave that we were given can be rewritten. Our r value is plugged in right here. Our phi is obviously plugged in right here. And we got our omega from either cosine or sine there. Okay, that's it. Erase those arrows and box that thing up and we're done. A quick note, if the differential equation we solved actually had an exponential in it, something like this, then in our final answer for this alternate form, we would have an exponential right here. So the process doesn't change at all. You just have to remember to stick that exponential in there. And now we need to make a much longer note. It has to do with this equation right here. Phi is the inverse tangent of some number. Recall this fact right here. Inverse tangent has a range of negative pi over 2 to pi over 2. What that means is, no matter what number you plug into your inverse tangent, your calculator is always going to spit out an answer between negative pi over 2 and pi over 2. So what we're saying is, using this technique, our phi values will only be right over there in the, the first and fourth quadrant. Now if we consider our original equations we got that related a, b, r, and phi, we can write them down right here. And if we consider this to be a circle with radius r, and there's some angle phi in here, then this point on the edge of the unit circle would be the point A, B. That's just trigonometry. Now let me reiterate that our calculator is only going to give us phi values between negative pi over 2 and positive pi over 2. However, we know that there are values for A and B that would require an angle that was outside of that range. More specifically, when A is a negative value, we will require a phi value that is outside the range of inverse tangent. So what do we do in this case? Well, the thing to realize is that if this situation is the situation that we have, and we plug inverse tangent of b over a into our calculator is not going to spit out this angle in the third quadrant. It's actually going to spit out this angle here in the first quadrant. So there's a correction we have to make. There's two possible ways to do this. One would be to say, well, we know that the difference between the angle our calculator spits out and the angle that we want is 180 degrees, or pi radians. The other correction we could make is to actually go back up here. I told you to remember that we could have had a negative value for r. And if we make our r value negative, that will actually make the correction that we need. So moral of the story is, if our a value is negative, we need to make a correction, and we can do that either by adding pi to our value for phi, or we can make our r value negative. And that's it. So the moment you've all been waiting for, let's get a video quiz here. It's number 7. We just want to rewrite this wave in the form of this wave. It's the same thing we've been doing above, but watch out, I'm pretty sneaky sometimes. So good luck, and I'll see you all in class.